everyone. Welcome to our premiere show of Chem Talks. Before we begin, let's play our game called Name That Part. Let's bring out our contestants, JJ Thompson, James Chadwick, and Ernest Rutherford. Hi, Thompson.
Hello.
So, Thompson, what exactly is an electron?
Well, I'm glad you asked because I discovered the electron myself. An electron is a negatively charged subatomic particle that creates a negative charge that balances the positive charge of a proton. Electrons are found in clouds and weigh 1 AMU.
Awesome job. Let's bring out our new contestant, Ernest Rutherford. So, Ernest, what is a proton?
Well, similar to Thomson, I too invented the proton. A proton is a tiny particle smaller than an atom. Protons are too small to see, even with an electron microscope. But we know they must be there because that's the only way we can explain how an atom behaves. To give you an idea how small a proton is, if an atom was the size of a football stadium, then a proton would be still smaller than a marble. It weighs the same as one electron, 1 AMU.
You're forgetting one thing, Ernest.
What?
What is the charge of a proton?
Oh, I think it's a positive charge.
You're correct. A proton is a positively charged subatomic particle. Thank you. Let's bring out James Chadwick. So, Chadwick, tell us, what is a neutron?
Similar to the previous scientists, I discovered the neutron. A neutron is a subatomic particle that has a neutral charge. They are located in the nucleus and have a mass of 0 AMU.
Awesome! Let's give it up for our contestants. Now, on to our main topic of today, isotopes. You may be asking, what is an isotope? So, here I'll tell you. Isotopes are atoms with the same number of protons, but they have a different number of neutrons. For the next bit, I'll need an audience member. You, with the glasses, come this way.
Hello, what will I be doing for you?
Well, as of right now, we will be calculating the average mass of this couch and both parts of the sofa.
Well, alright then. How do we calculate average atomic mass?
Great question. The way to calculate the average atomic mass is by multiplying the fractional abundance by the mass number of each isotope, then add them together. For example, we will be using the sofa and the table to calculate the fractional abundance. So, over here, the sofa weighs 23.985 AMU with the fractional abundance of 78.70%. In total, the table weighs 25.983 AMU with a fractional abundance of 11.17.
Awesome, I came up with the equation, so I multiplied 23.985 times 0.78 plus 25.983 times 0.11, which then equals 18.07 plus 2.86. Therefore, equals 20.93 AMU.
Does anyone know what rule number 1, Hund's rule, is?
I do.
What is the Hund's rule?
Every orbital in a sublevel is singly occupied before any orbital is doubly occupied. All of the electrons in a singly occupied orbitals have opposite spins because of the electrons repel each other.
Awesome job. Now, the second rule. Does anyone know what the Aufbau principle states?
I do. The Aufbau principle states that electrons orbiting one or more atoms will fill the lowest available energy levels before filling the higher levels. In this way, the electrons of an atom, molecule, or ion harmonize into the most stable electron configuration possible.
Now lastly, does anyone know what the Pauli exclusion principle states?
I do.
Pauli exclusion principle states that an orbital can contain a maximum of 2 electrons and those two electrons must have opposing spins. Wow, great job.
Thank you guys for being such a great audience. Now I'll be handing Chem Talks over to my co-host, Lafayette. Please welcome Lafayette.
Thank you, I'm Lafayette. Okay, everyone. Our next game is, can you draw the Bohr model of this element? The Bohr model was created by Thomas Bohr and shows the different shells occupied by the electrons. It also shows the amount of valence electrons an element has. I need an audience member, please.
Pick me, pick me.
Okay, you will be drawing the Bohr model of carbon.
Done. This is my Bohr model of carbon.
I would like to say thank you to the audience for coming to the premiere of our brand new show, Chem Talk. Yay!